Hello, hi everyone. Welcome to the student brand. This is your Shiva sir. Hello, hi everyone. Welcome to the student brand. This is your Shiva sir. Today topic is electric current. Electric current. Electric current. Myopia, 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 myopia. Near distance, we can hear. Far distance, we can see. Myopia, myopia, myopia. Myopia, myopia, myopia. For that correction, we are using concave lens, hypermetropia, 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 hypermetropia. Far distance we can see, near distance we can see. Hypermetropia, hypermetropia. For that correction, we are using convex lens, convex lens, convex lens, convex lens. New Cartesian sign convention, new Cartesian sign convention. All the distance measured from the point. Distance are positive along the incident rays. Distance are negative opposite to incident rays. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. All distance are measured from the pole. Distance are positive along the incident ray. Distance are negative opposite to incident ray. Distance are positive above the principal axis. Distance are negative below the principal axis. So now we are going to discuss about electric current, electric current, electric current, electric current. Electric current. So I'm considering here, so you can see electric current. Electric current is nothing but rate of flow of charge. Rate of flow of charge. Electric current is nothing but rate of flow of charge. Electric current is nothing but rate of flow of charge. So rate of flow of charge I equal to Q by T. I equal to Q by T. Yes, SI unit of current is ampere. Yes, SI unit of current is ampere. Yes, SI unit of charge. Yes, SI unit of charge. Yes, charge is coulomb. Yes, SI unit of current is ampere. Yes, SI unit of charge is coulomb. Yes, SI unit of time is second. So this is about electric current I equal to Q by T. I equal to Q by T. SI unit of current is ampere. SI unit of charge is. So SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb. 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 SI unit of time is second. So this is about ray electric current. Electric current. So SI unit of current is ampere. SI unit of charge is coulomb. So 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. So now I am considering here, if you inside of the conductor there are charges will move inside of the conductor. There are charges will move inside of the conductor. There are many charges will move. It won't be one or two. There are many charges will move. So that is will be considered as integral multiple. That is also known as quantization of charge. Quantization of charge. Q equal to plus or minus Ne. Why you are taking plus or minus? Why you are taking plus or minus? Because that is a quantization of charge you are considering. Quantization of charge. So there are number of electrons will move. Number of electrons will move inside of the conductor. So it not only one or two. So there are many. So that is the reason we are taking integral multiple plus or minus Ne. Plus or minus positive charge, negative charges will move inside of the conductor. That's why we are considering. That's why we are considering plus or minus Ne. So we are considering on one electron. On one electron you can take 1.6 into 10 power minus 19 coulomb. On one electron, on one electron, 1.6 into 10 power minus 19 coulomb. On one electron, the charge present on one electron is 1.6 into 10 power minus 19 coulomb. So in one coulomb, if you are taking 1 coulomb, 1 by 1.6 into 10 power minus 19. So if you are taking 1 by 1.6 into 10 power 19, that is nothing but 1 by 1.6 into 10. If you're taking 10 by 19, then you'll get, if you do this one, you'll get, so 10 by 16 into 10 power 19, then you'll get 0.625 into 10 power 19. So 0.625 into 10 power 19. Okay. So now you can consider, so in 1 coulomb, 6.25 into 10 power 18 electrons are present. In one coulomb 6.25 into 10 power 18 electrons are present. So this is about 1 electron, how much charge is present. On 1 electron, how much charge is present. On 1 electron 1.6 into 10 power minus 19 coulomb. So in 1 coulomb 6.25 into 10 power 18 electrons are present. 6.25 into 10 power 18 electrons are present. So this is about quantization of, this is about electric current, quantization of charge, and these values are very very important. 1 coulomb 6.25 into 10 power 18 electrons, and 1 electron 1.6 into 10 power 19 coulomb. So this is very very to discuss about. Now we are going to discuss about one more point. So that is about, if you are considering here. Now I am going to take one more point, that is electrical appliances. Electrical appliances. Dun, 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 dun. Electrical appliances. Electrical appliances. Those are electrical appliances. We'll discuss electrical appliances. Dun, 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 dun. Electrical appliances. Electrical appliances. Electrical appliances. Electrical appliances. Electrical appliances. So now I am considering electrical appliances. Those are electrical appliances. Now you are considering. Now you are considering here. Okay. So now. So first one is cell. First one is cell. This is cell, positive terminal, negative terminal cell. Second one is battery. Second one is battery. So positive terminal, negative terminal, battery, battery, battery. And the third one is switch. This is the open switch. Open switch. I am taking this open switch. Open switch. Open switch. This is open switch. Open switch. Open switch. Open switch. And closed switch. The fourth one is closed switch. Closed switch. Closed switch. So open switch and closed switch. Open switch and closed switch. Here I am considering here cell, battery, open switch, closed switch, and the fifth one if you are taking. Fifth one, resistor, 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 resistor. Sixth one. Next one, rheostat. This rheostat. We can take this resistor. So the device which is which is used to oppose the electric current in the circuit. The device which is used to oppose the electric current in the circuit is known as resistor. Rheostat is nothing but without changing the voltage source, which regulate the current in the circuit. Without changing the voltage source, which can regulate the current in the circuit, that is called rheostat. Rheostat. This is rheostat. Rheostat. Okay. So rheostat. Next one we are going to the ammeter and voltmeter. Seventh one ammeter. 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 Eighth one voltmeter. Ninth one, wire joining, 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 wire crossing, wire crossing, wire crossing, wire joining, wire crossing. 11th one is electrical bulb. What is that? Electrical bulb. What is this one? Electrical bulb. Electrical bulb. Electrical bulb. So cell, battery, open switch. Cell, battery, cell, battery, open switch, closed switch, resistor, rheostat. Once again, cell, battery, open switch, closed switch, resistor, rheostat. So ammeter, voltmeter, wire joining, wire crossing, bulb. So these are the electrical appliances. Okay, so we are using electrical appliances. So these are the electrical appliances. Now we are going to discuss about electrical circuit. Electrical circuit is nothing but so the current is electrical circuit. Electrical circuit is nothing but so a continuous and closed path of an electric current is known as a continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as An electric circuit. Electric circuit. A continuous and closed path of an electric current is known as electric circuit. Electric circuit is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. An electric circuit. So this is about an electric circuit. So now I'll explain. Right? Are you ready? Dun, 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 dun. So now a continuous and closed path of a continuous and closed path of an electric circuit. A continuous and closed path of an electric circuit. Electric current. Continuous and closed path of an electric current is known as an electric circuit. An electric circuit. Now you can see electric circuit. 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 Cell battery switch. Battery, ammeter, bulb, open switch, closed switch, current is passing. So the bulb is glowing, the bulb is glowing, the bulb is glowing because current is flowing. The bulb is glowing because of current is flowing inside of the circuit. Inside of the circuit, current is flowing. The bulb is glowing. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. Next one, we are going to the conventional current and electric current. Conventional current. Dun, 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 dun. Electric current. Electric current. Electric current. Electric current. Conventional current is nothing but the flow of positive charges will be considered as a conventional current. The flow of positive charges will be considered as a conventional current. The flow of electrons is known as the electric current. Conventional current, conventional current, electric current. So the flow of charges, the flow of positive charges will be considered as a conventional current. The flow of electrons will be considered as the electric current. Before finding proton, electron, so scientists were already given that statement. The flow of positive charges will be considered as a current. After knowing the flow of electron gives the current in the circuit. That's why. So instead of changing entire statement, better we can change the original statement. We can consider previous one as a conventional current. Next one is electric current. Electric current. Electric current. Electric current. Conventional current. Positive charges will move from high potential to low potential. Positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. Electrons will move from low potential to high potential. Positive charges will move from high potential to low potential, high potential to low potential. This is about conventional current and electric current, and also known as this is the electric circuit. What is an electric circuit? A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as electric circuit. An electric circuit. An electric circuit. Yes or no? Now potential difference. Potential difference. Potential difference. Potential difference. Work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge. Work done to bring unit positive charge from one point to another point within the conductor is called work done to bring unit positive charge. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Potential difference. Potential difference. Potential difference. Potential difference. Potential difference. So potential difference is nothing but work done to bring unit positive charge. Work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge from one point to another point within the conductor. I am taking here. This is the point A, point B, point A, point B. We are taking charge. We are doing work. We are doing work. We are doing work. We are doing work to bring unit positive charge from one point to another point within the conductor. Within the conductor. Within the conductor. Work done to bring unit positive charge from one point to another point within the conductor is called. Within the conductor is called potential difference. Potential difference. Potential difference. Potential difference. Work done to bring unit positive charge from one point to another point within the conductor. Within the conductor is called potential difference. Potential difference. Potential difference is denoted with the letter V. V, yes, potential difference. V equal to W by Q. V equal to W by Q. SI unit of potential difference is volt. SI unit of potential difference is volt. SI unit of potential difference is volt. SI unit of work is joule. SI unit of charge is coulomb. SI unit of potential difference is volt. SI unit of work is joule. SI unit of charge is coulomb. 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor. Within the conductor. Within the conductor. Within the conductor. Yes or no? Yes or no? So we are taking 1 volt equal to 1 joule of work is done to bring. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. That is called potential difference. 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 So electrical potential. Electrical potential. Electrical potential. Electrical potential. So this is the required field. This is the required field. So we are doing some work. So this is the infinity. So we are doing charge. So positive charge. We are bringing positive charge from one point, from infinity to the required field, 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 from infinity to the required field. We are doing some work to bring unit positive charge. We are doing some work to bring unit positive charge from infinity to the required field, from infinity to the required field, from infinity to the required field, from infinity to the required field is called electrical potential. Electrical potential. Electrical potential. Work done equal to so. So volt equal to W by Q, W by Q. So what is potential difference? Potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Yes, SI unit of potential difference is volt, SI unit of work is joule, SI unit of charges Coulomb. Coulomb, the electrical potential work done to bring unit pulse charge from infinity to the required field. From infinity to the required field is called electrical potential. Electrical potential. Electrical potential. Electrical potential. Electrical potential. Work done to bring unit pulse charge from infinity to the required field. Work done to bring unit pulse charge from one point to another point is called potential difference. Potential difference. Yes or no? Potential difference. So that is about potential difference and electrical potential. Electrical potential. Electrical potential. Next one is Ohm's law. 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 Dun 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 dun. Ohm's law. Ohm's law. Ohm's law. Dun 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 dun. Resistor. So here I am taking the resistor across potential difference. Across potential difference. Switch. I'm taking ammeter. So here I am considering this one is the closure switch, current is flowing. So positive terminal, negative terminal, potential. Current is flowing. So here you can take the current will passes from one cell first, next two cell, three cell and four cells. So first you have to join. So here I am considering the potential difference. This is the circuit diagram, schematic diagram for doing activity of Ohm's law, activity of Ohm's law. So V is directly proportional to the potential difference across the ends of the given metallic conductor. The potential difference across the ends of the given metallic conductor. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. So across this resistor, so I'm taking this is the resistor, so X and Y. So switch, this is the K I'm considering key. So ammeter, voltmeter, so 4 cells, 1.5 volt, 1, 2, 3, 4. 4 cells, 1.5 volts each, 1.5 volts each I'm taking here. The potential difference across the ends of the metallic conductor. The potential difference across the ends of the given metallic conductor. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. V equal to IR. V is directly proportional to I. V equal to IR. That is nothing but Ohm's law. That is nothing but Ohm's law. Ohm's law. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. Current flowing through it. Current flowing through it. Current flowing through it. Yes or no? Current flowing through it. So that is about circuit diagram. This is about circuit diagram. Circuit diagram. Circuit diagram. Okay, okay. So now you are considering, now I'm considering here. Okay, this is about Ohm's law. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at constant temperature. At constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. This is called Ohm's law. What are the materials required for Ohm's law? What are the materials required? Materials required for Ohm's law. Those are materials required. Materials required. First one, 1.5 volt. See how many cells? 1.5 volts each, 1.5 volts each, 1.5 volts each. Like that, 4 cells. 1.5 volts each, 1.5 volts each, 1.5 volts each, 1.5 volts each, like that. 4 cells, 4 cells. First one is 4 cells. 4 cells of 1.5 volts each. Second one, so nichromwire is an alloy of nickel, chromium, manganese and iron metals. Nichromwire is an alloy of zero point 0.5 meter length. And coming to third one, nichromwire is an alloy of nickel, chromium, manganese and iron metals. Ammeter. And fourth one, voltmeter, ammeter, voltmeter. Fifth, switch or key, we can say switch. Okay, switch I'm taking. Sixth one, connecting wires. Okay, so these are the materials required. So Ohm's law, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. So materials required, 4 cells of 1.5 volts each, nichrome wire, ammeter, voltmeter, switch, connecting wires. Procedure to do the activity. Procedure to do the activity. So procedure, first connect one cell and note down the reading of ammeter and voltmeter. Connect one cell and note down the reading of ammeter and voltmeter. Second one, connect to 2 cells. And note down the reading of ammeter and voltmeter. Connect 3 cells. Each and every time you are measuring potential difference and current, then you mention in the tabular form. So I'm drawing now. So you have to mention in this tabular form. Serial number of cells, ammeter, voltmeter, V by I form, that is R. So this is the V, R equal to V by I. So Ohm's law gives the definition of resistance. Ohm's law gives the Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. So here, if you draw the graph for VI, if you draw the graph for VI, VI graph gives the linear. So this is for ohmic conductors. For non-ohmic conductors, okay, ohmic conductors and non-ohmic conductors. So now you can see, so the potential difference across the ends of the given metallic conductor, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. So is directly proportional to current flowing through it. V is directly proportional to I, V equal to IR, R equal to V by I, R equal to V. For doing activity we need, we need, so 4 cells, 1.5 volts each, 1.5 volts each, 1.5 volts each, 1.5 volts each, like that. How many cells are there? 4 cells, 4 cells are there here. Nichromide is this one. Nichromide is an alloy of nickel, chromium, manganese and iron metals. Nichromide is an alloy of nickel, chromium, manganese and iron metals, and ammeter, voltmeter and switch and connecting wires. So these are the materials required. Okay. So for doing activity, first you have to connect one cell. Here you can see we are connecting one cell. Connect one cell and note down the reading of ammeter and voltmeter. Here ammeter is the current, voltmeter is the potential difference. V by I is nothing but R value. V by I is nothing but R value. V by I is nothing but R value. Here you can see. Connect one cell and note down the reading of ammeter and voltmeter. Connect two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. Repeat the process for 3 and 4. If you are repeating the process for 3 and 4, then after mentioning the tabular form, if you draw the graph for VI, so the graph is linear for ohmic conductors. The graph is linear for ohmic conductors starting from origin. Ohmic conductor means the substances which obey Ohm's law. Those are called ohmic conductor. The substances which does not obey Ohm's law, those are called non-ohmic conductor. For ohmic conductor, graph is linear. For non-ohmic conductor, graph is curve. Okay. So ohmic conductors, non-ohmic conductors. Ohmic conductor substances which obey Ohm's law, the substances which follow Ohm's law, the conductor which obey Ohm's law, those are called ohmic conductors. The conductor which does not, those are called non-ohmic conductors. I hope it is very clear. Next one. So we are going to the next one. Resistance and resistivity. We'll discuss. So small break will take. Okay. After break, we'll continue. Small break. So 4:50, I'll start once again. So next one, resistance and resistivity. So resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. Resistance Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. R is directly proportional to L by A. R equal to rho into L by A. So R is directly proportional to L. R is inversely proportional to area. R is directly proportional to L by A. R equal to rho into L by A. R equal to rho into L by A. So that is resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. R is directly proportional to L by A. R equal to rho into L by A. R equal to rho into L by A. So rho equal to RA by L. So SI unit of resistance is ohm, SI unit of area is meter square, SI unit of length is meter. So meter get cancelled, then rho equal to ohm meter. Then rho equal to ohm meter. So here considering resistance is directly proportional to length of the conductor, resistance is inversely proportional to area of the cross section, R is directly proportional to L by A, R equal to rho into L by A, rho equal to RA by L. So SI unit of resistance is ohm, SI unit of area is meter square, SI unit of length is meter. Meter get cancelled, we'll get ohm equal rho equal to ohm meter. SI unit of resistance is SI unit of resistance is SI unit of resistivity is ohm meter. SI unit of resistivity meter. Now we will discuss about difference between resistance and resistivity. Differences between resistance and resistivity. Difference between resistance and resistivity. So I'm taking here resistivity. R is the resistance, rho is the resistivity. R is the resistance, rho is the resistivity. Resistivity. So now you are considering. So first one is the formula of resistance is R equal to rho into L by A. So here first one rho equal to RA by L. RA by L. First one. Coming to the second one, SI unit of resistance is ohm. So that is SI unit. SI unit. Second one, SI unit of resistivity is ohm meter. Ohm meter. Ohm meter SI unit. SI unit. Now, so we are going to third one. Third one. So ohm is the symbol symbol of resistance. Ohm is the symbol of resistance. Symbol of resistance. So here ohm meter is the symbol. Ohm meter is the symbol. Now we are going to the one more. Okay. So fourth one, fourth one is, fourth one is, fourth one is. So resistance depends on length and area. Depending factors. Depends. So resistivity does not depend on length and area. So resistivity does not depend on length and area. Resistivity does not depend on length and area. Does not depend. Okay, does not depend on length and area. So fifth one. So resistance depends on temperature. Resistance depends on temperature. Resistivity depends also temperature. 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 Resistance depends on material of the conductor. Resistance depends on material of the conductor. Resistivity also depends on material of the conductor. Material of the conductor. Is it clear? Is it clear? So this is about resistance. Resistance. Okay. Resistance. Resistivity rho equal to RA by L. SI unit of resistance is ohm. SI unit of resistivity is ohm meter. So resistance is symbol and resistance depends on length and area. Resistivity depends on length, does not depend. Resistivity does not depend on length and area. So resistance depends on temperature. Resistance depends on material of the conductor. Resistivity depends on temperature. Resistivity depends on material of the conductor. Material of the conductor. So this is about. So this is about differences between resistance and resistivity. This is the difference between resistance and resistivity. So these are the difference between resistance and resistivity. Okay. So we are going to the one more. Okay. Chalo then. Next one. So resistance and resistivity. Resistance and resistivity. Resistivity. Resistance and resistivity. Resistance and resistivity. Ah, ah. Resistors are connected in series combination. Resistors are connected in series combination. Resistors are connected in series combination. Here, from Ohm's law, V is directly proportional to I, V equal to IR. From Ohm's law, V equal to IR, we can take V equal to IR from Ohm's law. From Ohm's law, V equal to IR. From Ohm's law, V equal to IR. Here, in this condition, so throughout the circuit current is same. Is equal to I1 equal to I2 equal to I3 equal to I, because current is same. So throughout the circuit, that's why I am considering here Vs is different. So the potential difference is coming from the battery. What of the potential difference is there? Okay. So here, so that will be equal to yeah. So Vs equal to V1 plus V2 plus V3. So I am writing that one. That is IRS equal to IR1 plus IR2 plus IR3. Okay. So now shall I take common I common? I is common. I am taking common Rs equal to I common R1 plus R2 plus R3. Rs equal to R1 plus R2 plus R3. So this is about resistors are connected in. Resistors are connected in parallel. So resistors are connected in series combination. Resistors are connected in series combination. Resistors are connected in series combination. If n number of resistors are connected in series combination, R is equal to NR. So if n number of resistors are connected in series combination, if n number of resistors are connected in series combination, R is equal to NR. Yes. So we are going to one more. Resistors are connected in parallel combination. Resistors are in parallel. Resistors are in parallel. So now R1, R2, R3, across R1, R2, R3 potential difference is there. So I am considering a potential difference is same. Vp equal to V1 equal to V2 equal to V3 equal to V, because potential difference is same entire R1, R2, R3, R1, R2, R3. So now I am considering current is dividing into three parts. Current is dividing into three parts. I1, I2, I3. So that's why we can take IP equal to I1 plus I2 plus I3. From Ohm's law, V equal to IR, I equal to V by R. So from this, V by RP equal to V by R1 plus V by R2 plus V by R3. So V I am taking common. V I am taking common. If you take V common, 1 by RP equal to 1. V I am taking common 1 by R1 plus 1 by R2 plus 1 by R3. We will get cancelled. The remaining thing is, if resistors are connected in parallel combination, 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula. Resistors are connected in parallel combination. Resistors are connected in parallel combination. So here, if R1, R2, R3 resistors are connected in parallel combination, potential difference is same across R1, R2, R3. So here we can take, so current is different because current is dividing I1, I2, I3. So current is dividing. That's why IP equal to I1 plus I2 plus I3. From Ohm's law, V equal to IR, I equal to V by I. So V by R, I equal to V by R. From that we can write V by RP, V by R1, V by R2, V by R3. So we can take common. V will get cancelled. V will get cancelled. Then the remaining value is 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is about resistors are connected in. Resistors are connected in parallel combination. Next one, heating effect of electric current. Heating effect of electric current. So heating effect of electric current. Heating effect of electric current. H. So we are taking V equal to H. V equal to W by Q. W equal to V into Q. Okay, so P equal to W by T. VQ by T. That is nothing but V into Q by T is I. Q by T is I current. So now we can take P equal to Vi. We know energy is given to the conductor, that is nothing but so P into T. P into T. Vi into T, that is nothing but V equal to IR. IR into I into T. That is the energies, that whatever the energy is given to the conductor, that will become into heat. So heat H equal to I square RT. H equal to I square RT. H equal to I square RT. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to, so resistance heat produced in the conductor is directly proportional to time. So this is about heating effect of electric current, applications of heating effect of electric current, electrical cooker, electrical oven, room heaters, and we can things. We can say for heating effect of electric current, applications of heating effect of electric current. Short circuit, direct contact of live wire in neutral wire takes place, then any amount of current will be drawn from the mains. That is about short circuit. And over voltage appliances on at a time, high voltage appliance on at a time, heavy amount of current will be drawn from the mains. It may leads to the short circuit. The potential in India is 220 volts. For live wire is 220, but for neutral wire is 0 volts. The difference between potential, the difference in potential difference between live wire and neutral wire. Live wire and neutral wire is 220 volts, and potential difference between live wire and earth wire is 220. Potential difference between neutral wire and earth wire is 0. And that is about fuse. Fuse is the safety device. Fuse is a safety device. Fuse is a safety device which safeguard the appliance whenever the extra current goes through the circuit. It melt and breaks the circuit. It safeguard the appliances. And earthing, heavy, if your extra current is there, that will send to the ground. So like metal bodies, metallic appliances, if you take, earthing will be there. Okay, extra current will be sent to the ground. So this is about electric currents. If you like this video, do like, share, and subscribe to Student the Brand. So if you like the content, you can inform your friends, ask them to join to the class. So if you like the explanation, if you like the channel, so I'm requesting you all. So you have so many questions regarding my outfit, regarding the costume. So I am not doing anything. I'm just teaching. So if you want more about this, you can go and check my YouTube. There are many videos are there. There are different costume. It's a part of the teaching. So nothing else is a part of the teaching. So it's representing. So this part of the one of the costume like that. So in different way, style of teaching. That's enough. Nothing else. If you want, you can go and check my YouTube channel. So you can check all the videos. Let me know if you have any doubts. So I'll be taking live classes. You can come and join it and you can understand. So that is about Student the Brand. So what I'm going to tell. So thank you so much for supporting, and so be support. I need your support. Please support me. Okay. So I'll come with great content. So thank you so much. This is Vaswasa from Student the Brand. Thank you. We'll see in the next live class.